In this lesson, we're going to be talking about graphing from slope-intercept form. By the end of this lesson, you should be able to graph lines from slope-intercept form and model real-world data with a graph. There are multiple ways that we can begin to graph a line. One of those ways is by making a table of values. You can also graph it if you have a direct variation equation by using the constant of proportionality or your slope and moving up and down from the origin. We can also graph things from slope-intercept form, which is what we're going to look at a little bit more today. Or if we have a standard form equation, we can graph using the x and the y intercepts. We're going to focus on graphing from slope-intercept form today, though. So when we graph from slope-intercept form, it's important for us to know what this equation looks like. This is our y equals mx plus b equation, where m represents the slope and b is the y-intercept. The y-intercept tells us where we should start on our graph. So it tells us where along the y-axis we should find a point. And then the slope tells us how we should be moving from that point to get to the next point. It tells us if we need to move up or down or left or right to get from one point to the next. We can also write slope-intercept form equations from graphs, from tables, and from word problems by looking at, by finding these different things. So from a table, we would need to find the rate of change, or the change in the y's, or the change in the x's. So look at how the y's are changing compared to the x's, and then find the y-intercept where it's 0. And then from word problems, by looking for these keywords that tell us a rate is happening like per, and that tells us when the y-intercept is happening like a beginning or a fixed amount. When we graph a line, then we can better identify the key features of that line, which is what we were working on in previous lessons. Those key features of our linear graph, this is our domain and range. This tells us all the elements that make up our graph. So remember, domain is measured from left to right. So we're looking at all the values our graph contains from left to right. Our range is from up and down, so from bottom to top. All the values that make up our y's. We can identify the x and the y-intercepts, so where it crosses our two axes. And then the slope, which is how it's changing from one point to the next. Remember that when we're dealing with real-world situations, that we want to take those into consideration when identifying those key features. When we're graphing the equation, again, we can graph the equation from a table by plugging in known x values. So, such as we typically just pick the same ones each time. So we pick some x values like -2, -1, 0, 1, and 2. Because we know it will have those values. And then we'll get out the y's, and then that will tell us our points. We can use a direct variation equation if it's proportional, where we'd start at the 0 and then follow the slope. And then for the slope-intercept form equation, we start at b, and we use the slope to get from one point to the next. All right, let's look at some examples. So here we have a line that's already graphed for us. What we want to do is we want to identify its key features, such as the domain, the range, the x and the y-intercepts. So when we're listing domain and range, remember that we're listing it as an inequality unless it's discrete. And this is continuous because this graph is all connected. These are not separate points. So our domain, remember, is from left to right. So where do we start on the left? Where do we end at the right? Well, we start at 0. And we end at 4. So we start at 0, and we end all the way at 4. We're talking about the range. The range, again, is going to be written as an inequality unless it is discrete, which this is not. Our range starts at the bottom, so starts at 0. And we end at 20. We're talking about our x-intercept. This is where it crosses the x-axis. So we cross the x-axis, or we intercept the x-axis at 4, 0, where we're listing the intercepts as a point. And for the y-intercept, we cross the y-intercept, or intersect the y-intercept at 0, 20. If we want to find the rate of change, we would look at the change in the x's and the changes in the y's. So remember, we're looking at change in y over change in x. So here's my y. So we go from one point to the next. So here's 2 points that I know are on my graph. So if I look at my change in my y's, I'm decreasing, going down from 20 to 0, so that would be a negative change of 20. And for my change in my x's, I'm at 0, and I go all the way to 4, so I have a change of positive 4. Negative 20 over positive 4 gives me negative 5. So remember that when we're finding slope from a table, we're looking at our change in our y's, so our vertical change over our change in our x's, which is our horizontal change. We're going to graph the following using the given information. So here we have a table. So remember that one of the ways that we can graph a linear relationship is if we have a table. So we have a word problem. It says John is filling up a trough with water that has a depth of 2 feet. And so these are the values that we have. Now we know 2 feet. The max that we could go up to in inches would be 24. And so we could continue to follow this change. This is a change of plus, looks like 6, and then plus 3, and plus 6, and plus 3. So it looks like this is, our intervals here are although they're not the same, they're proportional. 6 over, oh, this would be a 3. Okay. 3 over 2 is the same thing as 6 over 4. So if we're looking at change in y over change in x, we know that our change in y, which is 3 over 2, would be the same thing as 6 over 4. So there's our slope. All right. So if we start graphing these points, I know that I have a point at 2, 3. I know that we have a point at 4, 6. We have a point at 8, 12. We have a point at 10 and 15. We have a point at 14 and 21. So I can continue this pattern. All right. Now my graph's a little off here, so it would actually start at 0. But here's our linear relationship. Now, if we want to list the domain and the range, and let me go back for just a second. Here's how we know that our point goes to 0. If I continue this pattern in the table and I go back, and we want to find the line-intercept. So if I go back 2, every time this side's increasing by 2, this side's increasing by 3. So go back 3. So at 0 minutes, there was 0 inches of water in the trough. So we know that it has to go through 0. So there, we have a point here based off of that. Okay, so if we're listing our domain starts at 0. So we have a max of 0 minutes. And if I continue, we can only go up to 2 feet. So it can't be going on forever. So to get from 21 to 24, which would be 2 feet, we add 3. If I'm adding 3 on this side, anytime we add 3 over here, we're adding 2. So if I add 2 here, this would give me 16. And so I'm either at 0 minutes or my max time is 16 minutes. When I'm at 0 minutes, we have 0 water. And when I'm at 16 minutes, we have 24 inches or 2 feet of water. Our x-intercept is at 0, 0 because it touches at the origin. And that also happens to be our y-intercept. We're going to graph the following using the given information, and we want to describe the key features. So we have a slope, and we know that it passes through the point negative 3, 4. So we have a point, negative 3, 4. So we're going to put that point. We know the slope, which is 2 over negative 2 over 3. So this tells me I can go up, or not up, my bad. This tells me that I can go down 2 and right 3. Or we could change it, right, so that it's 2 over negative 3. And I could go up 2 and left 3. So down 2 and right 3, that'll take me there. Up 2 and left 3. will take me here. I can connect that. Ooh, I plotted, I just tried to plot the wrong point. So negative 3, 4 is up here. Negative 3 and 4, let's try that again. Alright, so if I go down 2 and right 3, that puts me here. And down 2 and right 3 puts me here. Down 2, right 3 puts me here. And then if I go up 2 and left 3, that puts me here. Now we have our graph. Alright, our domain and our range, because we don't have a real world situation here, our line extends forever, we assume that it keeps going on forever. So both our domain and our range are all real numbers, because it's going to go on forever in both directions. Remember that our x-intercept is where it crosses the x-axis, so that's at 3, 0. Our y-intercept is where it crosses the y-axis, that's at 0, 2. And they gave us our slope, which was negative 2 over 3, or 2 over negative 3. Here we have slope-intercept form. We're going to graph using this equation. For graphing, remember that we are starting at our y-intercept. So this tells us that on our graph we need to start at 6. Our slope tells us how we're moving, so negative 3 or negative 3 over 1. We want to change that to a fraction because we need a vertical and a horizontal change. So this tells me I can go down 3 and right 1. So if we go down 3 and right 1, we have a point here. Down 3 and right 1. Down 3 and right 1. Down 3 and right 1. Again, no real world situation here, so we assume that it goes on forever in both directions. So again, our domain and our range, all real numbers. Again, our x-intercept is where it crosses the x-axis, that's at 2, 0. Y-intercept is where it crosses the y-axis, that's at 0, 6. And our slope of negative 3. To graph a line from slope-intercept form is what I would like you to consider before watching the next video. As usual, please subscribe to the channel so that you get updates as new videos are released.